So we have seen in the beginning voltage series feedback. Whenever you have voltage series feedback, the input resistance will increase, because you see input side I have series mixing. Resistance will be increasing in series. That is proved here. You see RIF equal to RI is multiplied by 1 plus A beta AV dash. So which means that my input resistance is increasing with feedback. If you put beta equal to 0, if there is no feedback, then you will get RIF equal to RI. Sorry. So when you don't have feedback, everything will become same. RIF will be equal to RI. Because of presence of feedback, negative feedback, your input resistance with feedback is increasing. See, in all the 4 types of amplifiers, we'll be applying KVL, KCL only. So you should be very, very thorough in applying KVL and KCL across the 4 networks, whatever we are going to see. First one, we have seen voltage series feedback. So the input side, I have applied KVL. On the output side, I have applied KVL. I have simplified and got the answer for RIF. RIF equal to Vs by Ia. So it is Ri into 1 plus beta AV dash. Ri is the resistance without feedback. RIF is the input resistance of the amplifier with feedback. Beta is the feedback factor. And AV dash, we know you simplified this big term to be AV dash. So AV dash equal to AV into RL by R0 plus RL. Is it clear? So whatever in theory we have said that input impedance will increase, we have proved it mathematically that for an voltage series feedback network, my input resistance with feedback is going to be increasing enormously. Assuming that this 1 plus beta AV dash is a very big number, so RI is multiplied by such a huge number. So my RIF is going to be very, very larger in magnitude when compared to RI. Okay. So AV is going to be the voltage open circuit gain without feedback. So you can write the value of AV is going to be AV dash. In AV dash expression, you put RL equal to infinity. So if you put RL equal to infinity, all parameters are considered without the load, because the load is not a part of your amplifier. Load is considered externally. So if I want to find only the amplifier gain, then I should open my load. So opening my load is equivalent to putting RL equal to infinity. So when you put RL equal to infinity in this expression, your AV dash will be equal to AV. Okay, so you apply L'Hospital's rule, all take RL as common, then you apply RL equal to infinity, you will get AV dash equal to AV. That's what they are saying here. AV is actually the open circuit voltage gain without feedback. So how you will get AV from AV dash? In AV dash expression, you have to put RL equal to infinity. That way you get what is your actual voltage gain of your amplifier.